Performing. Greetings everyone, this is Gaundar Meghraj Gandhi along with my co-mates Govind KP and Hari Vignesh. We are performing a test on emission characteristics on diesel engine with alternate fuel blends and nano additives guided by Mr. M. Sandal Kumar. So see, like, the world is facing various hazardous issue because of this pollution and all this stuff. We are trying to give a better and proper solution for it. The thing is, like, nowadays the use of petroleum products in vehicles are both costly and hazardous to the environment. The world is looking for alternative fuels to fulfill their transportation needs. In this project, we are experimenting on Jatropha biodiesel. We are preparing a biodiesel blend consisting of Jatropha biodiesel and silver titanium dioxide (AgTiO2), which will be explained later. That why are we specifically using AgTiO2 in this particular blend along with the biodiesel. Now, after preparing the blend, we are going to find out the emission characteristics of the diesel engine and compare that with the characteristics of the existing diesel. Now, to introduce the thing, the renewable transportation fuels are ethanol and fuels derived from animal fats and vegetable oils. The choice of vegetable oil as engine fuel is to reduce emissions. There are various oils which are being considered worldwide for the use of engines. These include Jatropha, Karanja, rice bran, and some sunflower oils, and even the soybean oil. Now the thing is, vegetable oil has a viscosity that is higher than the viscosity of the conventional diesel. Thus there is a need for modification of the oil to reduce viscosity and to make it more suitable and sustainable for the engines. Now for this particular thing, we went through the literature survey, and we found out various explanatory methods which can literally explain problems which we are facing today. Like, we studied paper written by PK Sahu, LM Das, MKG Babu, and all those stuff, giving that, like, biodiesel production of more than 20% of the blend tends to decrease the BSFC. It is seen that during part of throttle test mode, blends with higher percentage of biodiesel in diesel tends to decrease the exhaust smoke and all these things. These are the things which we collected. Like, other papers which we have collected are they literally mean that the oxides are being reduced. Oxides of sulfur, CO2, HC, and all those stuffs are being reduced, and the eventual performance quality is being enhanced. This is what we have referred to through 2 or 3 papers that we have gone through, and the list of the papers are being given in the PPT. Now, to define the problem, we are going to find performance and emission characteristics of Jatropha biodiesel with AgTiO2 as the nanoparticle. Components of the fuel blend are 90% of diesel. That is, there are 2 blends actually comprising of 90 and 70% of diesel, and combined to which 10% and 30% of Jatropha biodiesel, in which 25 ppm or 25 mg per liter of AgTiO2 is added. Then we are going to compare their characteristics to the biodiesel blends. Now it is like, we are predicting that what are the outcomes that we do expect. We expect the fuel blends with additive to perform better than commercial diesel in both performance and emission characteristics. We want to reduce the emission by 10%, increase brake thermal efficiency and brake specific fuel consumption by 5 to 10%, which will enhance the engine's performance quality. Now let us go through the complete methodology that we are following. See, as I told you, the literature survey is being done continuously, considering the various papers and all those stuff. We have collected everything, that which is the best one to do the work. Fine. Now we purchase the materials like the biodiesel, Jatropha thing, and the nano additive, that is AgTiO2, was purchased, and we brought it into the simulation and all those stuff. And after which, the most essential thing was, like, we had to mix the biodiesel and the nano additive to its particulate level so that the emission standards which we get are perfect because of the continuous blending into it. Now then we went through the theoretical calculation, and after the theoretical calculation, the comparison of the results was done. Now, Now to go on with the engine specification as it is given in the PPT. The engine specifications are: the engine is Kirloskar TV5. It is like the Kirloskar TV1 diesel engine. This engine is selected because most of the Indian engines, that is like the work which is done by most of the Indian engines, comprises of the same engine which is being used by us. Now the power, cylinder arrangement, speed, cooling arrangement, everything is being assisted and assigned very logically into the PPT. Now we go through the speed that the engine runs on a constant speed. Cooling arrangement is a water cooled. The cylinder bore is 87.50 mm. Stroke length is 110.00. Connecting rod length is 234. Compression ratio is 17.50. Swept volume is 661.45 cc. Now let us go through the performance characteristics which are to be taken in a huge consideration. So the brake specific fuel consumption is like, it is like the brake specific fuel consumption, it is not reducing to that drastically, but the best results which we are getting is by B30 added with the nano additive. That is like 30% of the nano additive and 70% of the thing. 30% of the nano additive along with the biodiesel, and 70% is the conventional diesel. Now let's go on with the brake thermal efficiency. It is like similar for each type of fuel blends, but the height is but the highest is B10. This is due to the better combustion and better mixing of the air and the fuel. Now it is over 3.3% increase in BTE, and it is because we are using AgTiO2 into it. Now AgTiO2, what it does is, TiO2 is a lubricant and it enhances the combustion in a particular way, because Ti gets separated from O2 and the O2 gets into the combustion process and the combustion is complete, because of which the oxides, the various HCs and other gases are reduced very drastically. Now let us go on with the emission considerations and all those stuff. So this is like Jatropha biodiesel. CO emission results are: the carbon monoxide and hydrocarbon emissions are reduced by 14 and 12%. The reason for HC reduction is the oxygen and nano additive acting as buffer for the better consumption, as I told you before. This is also the reason for the reduction of CO. Now let's move on with the HC is done, the CO is done, and now let's move on with CO2. The reason for increase in NOx is the increased temperature in high loads. The high temperature leads to the formation of NOx essentially. Now smoke opacity is lower. Smoke opacity is lower in the nano additive due to the complete combustion that happens in them compared to the normal blends. The additives acts as a buffer and improves the combustion and ignition. As I told you, this is completely because of the AgTiO2 which is present into it. The Ti gets separate, O2 gets separate, and they eventually and individually act as a combustion enhancer, so that the thing is totally liquid. The thing is totally in a scrutiny and works very logically. Now to conclude the project, a stable dispersion of AgTiO2 nanoparticles in biodiesel was obtained using sonification. It is observed that there is a marginal increase of 3.3% as maximum load in BTE when AgTiO2 nanoparticles are used as fuel additive in diesel fuel. Addition to AgTiO2 nanoparticles also result in an increase in NOx emissions of 5% at maximum load. However, a decrease in the emission of unburnt hydrocarbons by 12% and carbon monoxide by 14% at maximum load is observed with the addition of TiO2 nanoparticles in diesel. So this is how we achieved all these stuff, and this is the chronology that we followed till the end of the project. And this we feel like this will be giving us a proper way, a proper thinking, a proper chronology through which we can approach the problem with a better fuel, which is which is not destroying the environment completely, and it's environment friendly. With this intention, thank you.